Find the distance from the point 5, 3 to the line 2x plus 3y equals negative 7. Note on your paper, it's a typo. It only says a positive 7. Add in the negative. So now that we have this problem, find the distance from the point 5, 3 to the line 2x plus 3y equals negative 7. Look how simple this problem is, but there's so much going on to it. Let's take a look. How are we going to approach this? The first thing, when we're looking at this, most people don't really have an idea on what to do to approach it. When you don't have an idea, let's see, can we do some of the basic things? How can we do? We have a graph, our XY axis set up so we could graph it. Let's do that. Let's take this equation and solve it for y. We'll put it into y equals mx plus b form. Negative 2x minus 7. Y equals negative 2/3 x minus 7 over 3. Now we don't need to really graph it. We can sketch it. Remember, my use of the word sketch in the books are two different things. I just want the rough idea. When the book says sketch, it really means graph it, plot points. This has a negative y-intercept and a negative slope. So some negative y-intercept and a negative slope. We have a point 5, 3 somewhere in the first quadrant, and we need to find the distance from this point to this line. Well, how do you measure distance? Can I connect this point 5, 3 to any point on the line? Would that any point work for the distance? No. What I need to do is I need to go the perpendicular. I need to go the shortest route, and would be something like this. That's key for finding this distance. So now that we've done this, what we really are saying is I need to find that point. Once I have that point, then I can find the distance between them like we've done before. Well, how do you find that point? This point is special because it's the intersection between our given line and this dotted line. Well, in order to find that point, I already have the given line. I need to find the equation of the dotted line. Once I have that, I can solve that system and find this point. Now the question becomes, how do I find the equation of this line? Well, what's special about this line? It's perpendicular to the given line, so that tells us what? Something about the slopes. That the slopes are opposite and reciprocal. And it goes through a point. Well, if I have the slope and a point, I can write the equation of a line. And that tells us exactly what we need to do. We need to find the equation of the dotted line, so we want to find the equation of the perpendicular line. We know the slope of this line is negative 2/3, so this slope of our perpendicular line will be opposite in sign, so positive, and then flip the fraction. Now we have the point 5, 3, so we can write the equation. Again, let's put it into point slope. Y minus 3 equals 3/2 times the quantity of x minus 5. Since we're going to be solving the system of equations, let's move it into standard form where we have ax plus by on the same side. So we want to get rid of this fraction. Let's multiply every single thing by 2. We have a 2 times all of that and a 2 times all of this over here. So the 2's distributed will be 2y minus 6, and on the right side they'll reduce out to give us 3x minus 15. Let's move everything so the x, keep the x positive, so we have 3x. We'll move the 2y to the right. That'll make it negative 2y. We'll add 15 to both sides, and that'll give us 9. So now we have the equation of our perpendicular line. Our next one is find the point of intersection. Yep. 9 equals 3x minus 2y, and the given line was 2x plus 3y equals negative 7. Now we can get rid of either variable we want, x or y. Since the y's are opposite in sign right now, let's get rid of that. We'll multiply the top by 3 and the bottom by 2. We'll have 27 equals 9x minus 6y, and negative 14 equals 4x plus 6y. Add them together. 13 equals 13x, and that gives us 0, so x equals 1. Plug it back into one of the two equations to find out what the y value is. It really doesn't matter. Since we're finding y and this is positive, I'd rather use that than the negative. So we'll have negative 7 equals 2 times 1 plus 3y. This is 2. Subtract 2 from both sides. We get negative 9 equals 3y. So y equals negative 3. Now we have our point, which is 1 comma negative 3. And the next step is to find that distance. So the distance now, distance between 1, negative 3 and 5 comma 3. We can go back to our graph here and call this 1, negative 3. So we need to find the horizontal and the vertical change. This will be 3 minus negative 3, which will give us 6, and 5 minus 1, which will give us 4. So we'll have that distance equals the square root of 6 squared plus 4 squared, 36 plus 16, 4652. Let's see, does anything go into 52? 4 does. This will be 4 times 13, or in other words, 2 root 13. So now that's the entire problem. Look how simple that question was in such a short space, but in it we had to review almost everything we've done. We had to find a perpendicular slope, find the equation of a line, solve a system of equations, find the distance between 2 points. It's a very nice problem.